Hi everyone, welcome to UChicago ICPC. Today we will walk through Codeforces round 1004, problem C, Devyatkino. This problem states that given a number n, we can add numbers containing only with digit 9. Numbers with only digits of 9. What's the minimum operation to get a digit containing 7? To get a digit of 7. For example, the number 10, how many operations we can perform to get a 7? We can first add a 9. So by numbers with 9, we can add 9, 99, or 999, etc. Here, let's try adding a 9. We get 19. What's next? Can we also add a 9 again? We will get 28. And then add another 9. We get a 7, 37. This is example 1. Here n is 10, and one sequence of operation is just adding 3 9. So we can use 3 operations to produce a digit of 7. As you can see, can we always get a 9 for any number? So the first idea is it possible to always get a 7? This is true because as you observe here, if the number is 1, 0, we add the first 9, we get 9, and then get 8, and then we get 7. So if we observe the last digit, we can always add a 9, and then decrease it from 9, 8 to 7. And every time, we decrease by 1 after adding a 9. So after adding a 9 from 9 to 8, we decrease the value by 1. Therefore, if the example 2 n is 19, we can just add a 9, and then 9 will be decreased to 8, and then add a 9, it will decrease to 7. Therefore, it is always possible to get a 7 by decreasing the number until it reaches 7. And what if the digit is less than 7? So you see example 1. The digit is 0. And what to do? We can add a 9 and it will become 9. So what if n is equals to 11? After adding a 9, 1 decreased by 1 is 0, and we add a 9 again, 0 decreased by 1 becomes what? Becomes 0. Therefore, we always, for the last digit, can decrease it by 1, and 0 will become 9 again. So this loop from 2, 1, 0, and then go back to 9. One of those values will always be 7. Therefore, it is true. And how many operations at most do we need to use to get a 7? The max number of ops is just 9, right? Because from the loop, by doing it 9 times, at least one of them we will get the 7, because we will decrease 9, 8 until 0 and then rotate back to 9. So now we just need to find the minimum operations to get a 7. Here, as you can see, it did that for every digit, we can decrease it by 1. But what about the other positions besides the last position? So for the last position, so let's give an example. So first, observation, last digit can always be decreased by 1. What about the middle digits? Can we also always decrease it by 1? If so, shouldn't we just loop through all the digits? For example 4, where n is equal to 3, 8, 2. Can we always decrease the middle digit by 1? This is because if we can decrease it, we just get 7 in one operation. But let's try adding a 9 here. Or adding a 99, because using 9 plus 8 should give us a 7. However, we can't just add a 9 in the middle. We always need to append a 9 for the positions lower than it. So 99 will be our the best optimal choice. So adding 382 with 99, we get 2 plus 9 equals 1. So this carry on will yield another 8, because 1 plus 9 plus 8 is just 18, and this carryover will 4. So we see that we can't decrease the middle figure, and that is a very big problem. But if we add a 9, what will happen? So let's start with n equals 382 again. If we add a 9, we get the last digit being 1, this being 9. So we are able to increase it. Can increase. But can we always increase? Can we always decrease it by 1? No. Can we always increase it by 1? For example, n is 380. Now, you might think that we can't have a carry on that easy because it's 0 at the last position. But if the last position is 0, shouldn't we just add a 99 here? And now this 8 will be our last position, and we'll get a 7 directly. 9 plus 8 will be 7. So it's actually a good thing if the last digit is 0. And if the number is 390, we add the 99, we get 489. And now, what to do? Here, 9 becomes 8. We decrease it. But then, we seem to be only able to increase it again. So, either we add a 9 to increase it to 9, or add a 99 to decrease it, to maintain as 8. So sometimes we can't always increase. No and no. Therefore, we have to think about something else. Idea 2. Second idea. It's very unlikely to add a 99 because we can't determine what will happen to the middle digits. But what if add idea 2, can we always increase a digit by 1? And how to do that? If we are allowed to add numbers like 1 with a bunch of zeros, we can just directly increase any digit by 1. So if we are allowed to add numbers with 1 following a bunch of zeros, we can increase any digits by 1. We observe that 999 is not so different from 1000, right? So this is just 2, 3, 4, 5, 5, 9 plus 1, isn't it? So this is just so if we add a 999, 999 equals just adding 1 with 3 zeros minus 1. $99 is just 100 minus 1, and 9 is just 10 minus 1. Therefore, if we perform k additions, we will add k numbers of this 1, 0 configuration and subtract how many ones? Is it just k ones? So after k operations, we will subtract k number of ones, which is just k. So observing this, if we set the target which is our n to be n minus k, we can always increase a digit by 1. This is because after changing the target n into n minus k, it's essentially saying we can now use 1, 0 configurations, like 1,000, 110, k times, because we will subtract k. And here is the subtracting k part. So if we want to rechange our target to n minus k, we can freely use those numbers, those whole numbers. And in this way, the things will be so much easier. For example, if n is 36, what's n minus k? N minus k is, so we first need to decide what k to put. But k, what's the, so k is our answer, the minimum operations. And what's the maximum of k? Isn't it just 7? Isn't it just 9? So within 9 operations, we can always get a 7. So k is just from 0 to 9. Then we can just try add all the k's. So k is our answer. We can try all answers. So we can try all the answers. All the answers k from starting from 0. So with using 0 operations, so what is k? K is guess the number of operations. Let's try k is 1. So using one operation, can we arrive at 36? So try k equals to 1. This n minus k is 35. Can we achieve a digit of 7 using 1 operations? So how to make the last digit 5 to 7? Now we can increase it by 1, right? So we can use 2 operations, which is adding 1 twice. So using 2 operations, we can get the last 1 to 7. For 3, how many operations to get to 7? 7 minus 3 is 4. And the min operation is just taking the min of those. Min operation is 2. So not satisfied because we try the answer of 1. So we say that there's only 1 operation, but we couldn't achieve it with 1 operation. Now let's try k is 2. The number of operation, and minus k is 34. How to get the last digit of 4 to 7? We need to increase it 3 times, and for 3 to 7, we still need 4 times. So the min number of times operations is just 3. And 3 is larger than 2. Cancel. How about try k is 3, and minus k is 33. So both of them to get to 7. Both of them increase by 4. So the min operation is 4. Larger than 3, not true. At last, try k is 4, and minus k is 32. And for 3 to reach 7, for 3 to reach 7 is 4, for 2 to reach 7 is 5, and the min is selecting 3 to approach 7, which is using 4 operations, which matches or less than equal to the guess of 4, so this is correct. Therefore, the correct minimum number of operations is 4. How can we see this in the example? Our goal is to increase the first digit, 3, to 7. So let's see, can we do it in 4 operations? Let's first add a 9 here, becomes 45, add another 9, 54, add another 9, 63, add another 9, 72. So we added 1, 2, 3, 4, 4 times, and boosted 3 to 7. Therefore, by using this formula, and minus k, which is 32, we see we can just loop through every digit, 3 and 2, and see how much they are away from our desired set. So the algorithm is for letting try all the k, try k from 0 to 9. So if the number has 4 or 5 positions, try k maybe being 4, we just check whether each position, just say this number is 1, 2, 3, 4, 5, how much each position, this is n minus k. We first calculate n minus k. We'll say that it is just 1, 2, 3, 4, 5. We will loop through each digit. Loop each digit and see how many operations we need to add it to make it a 7. And digit see difference to 7. And take min. So here, 5 and 7 has a difference of 2. 4 and 7 has a difference of 3. And this has a difference of 4. And taking all the difference and taking the min among all of the difference, we get the min difference is 2. And then check whether 2 is within the guess of k. What's the time complexity? Because k can range from 0 to 9, we will do it 9 times. K will be 9 times, and for each loop, we will loop through all the digits times number of digits. And taking the min and checking is O1 operations. So the time complexity is 9 times the number of digits, which is log 10 of n. Number of digits of n. So the algorithm's time complexity is just log n. Since n is very big, 10 to the 9th, log n is the correct time complexity. Thank you very much.